Divide. So far, so good? Divide x cubed plus 4x squared plus 5x minus 2 by x plus 2. Is that what you guys have? Thank you. Now, if you remember your long division back in the day, you probably had lined paper, and teacher would say, turn your paper so you see your columns. You sort of want to do that here. Don't actually have to turn your paper. You want to align your columns so your divisor is x plus 2. And the cubic is the dividend. This happens to be a nice problem. Nice meaning because there's no gaps in the divisor or the dividend. If there were gaps, you'd have to put zeros in there. Fill them up. Unlike when we have numbers, we know how many times 5 goes into 42. It can only go at most 8 times. However, we don't know how many times x plus 2 goes into this cubic. So instead, you only look at the leading term. What's the leading term of the dividend? X cubed, the whole term, not the degree. And what's the leading term of the divisor? X. So if you divided the leading term by the leading term, you get x squared. So you put that in the x squared column, which is the second one. After we got our number for the quotient, what do we do next? Multiply it. So what's x squared times x? X cubed, yep. And then times the 2 plus 2x squared. So make sure your columns are lined up. Now what do we do? Subtract. So you can do this one of two ways. You can do subtraction and put parentheses around it. Or if you want to distribute a negative through an add, totally fine, whatever you're comfortable with. Regardless of how it's done, you should end up with the same answer. What happens to the x cubes? Cancel. Your first term should always cancel. And then 4x squared minus 2x squared is 2x squared. Are we done? Heck no. Bring down the rest. We'll use a different color for emphasis. All right, we're not done. Leading term over the leading term. So 2x squared now over x. What is that? 2x. Put that up top in the x column. Now what? Multiply. What is 2x times x? And times 2. Subtract. What happens to the 2x squareds? How many x's do we have? Are we done? Nope. Wash, rinse, repeat. What goes up top? Plus 1. Is everyone comfortable with why there's a plus 1 here? Sure. Take the leading term, which is x, divided by the leading term, which is also x. So x over x would be 1. So anytime you're trying to figure out what goes up top, it's leading term of the dividend and the leading term of the divisor. Go on.
But if you take that
So the goal is every time is to cancel out the leading terms. And that drops you down your degrees. It may cancel out the whole thing, but it's not the point. Yeah, it's great if it does, but it doesn't have to. If we multiply by 1, we get x plus 2. Subtract. X's are gone. What's our constant? Negative 4. Now are we done? Yes. And here's how you know when you're done with long division. If the degree of the remainder is less than the degree of the divisor, you're done. What is the degree of the remainder? 0. What is the degree of the divisor? 1. Usually 0 is less than 1. So we're done. So if the degree of the remainder is less than the degree of the divisor, stop. For me, you can stop here. If you want to be fancy, you can say plus -4 over x plus 2. That's cool. I don't need to see that. I'll just assume that that's comfortable for everyone. Okay. All right. So that's long division, basically. For funsies, let's continue with this. Funsies. Suppose we have the function f of x is x cubed plus 4x squared plus 5x minus 2. And I want you to find f of -2. So if you would, plug in -2 in for all those x's. Yeah, -4. Where else on the screen do we see a -4? It's right here. It's your remainder. This is getting into the remainder theorem.